So hi guys, we're back with another video that is we're going to discuss about the properties of sounds. That is, we're going to discuss about the characteristics of sound, right? So when we talk about characteristics of sound, we mainly have three characteristics. That is the pitch, the loudness, and the quality of sound, right? So in this tutorial, we're going to discuss questions related to that topic, and more importantly, the higher priority is going to be given to the loudness part, right? So these are basic uh, questions, theory questions. So therefore, maybe I'll skip them and move on to some calculation parts, right? So yes, let us discuss from the seventh question onwards. So in the sixth one, right? Let's move on to the sixth question onwards. It says at a point 10 meters from a small source of sound, the intensity was this much, 0.7 watt per square meters. Find the power of emission of sound energy. We need to find the power of emission of sound energy, right? All right. So maybe let us discuss it, right? So it's the sixth problem, right? Yeah. So it's the sixth problem. So it says at a certain point, there is a sound source, right? So at a distance, at a distance, 10 meters, is it? Is it the case? At a distance 10 meters, we need to say there was as a sound intensity of this much was heard, right? At a distance r equals 10 meters, a sound intensity, for example, if we consider this point as point a sound intensity was heard of 0.7, is it the case? 0.7, right? Yeah, 0.7 watts per square meters was heard, right? So we need to find the power of this sound source, right? We know the equation, intensity is equal to the energy over unit area into unit time, right? And also intensity is equal to, if we consider this E over T, energy over time. So what is the rate of energy called as the power? So it's power over area. So what is the unit area when sound receives to this point? Actually, it's not going to receive only to this point. It's going to go in all the directions, right? The sound is going to travel in all the directions, right? So at when the sound wave reaches the point A, it it's going to it's going to reach to an area of how much? If you see the area, it's going to be something like, if you consider the three-dimensional space, right? So the sound is going to uh, reach a sphere. It's going to be reach a sphere. So the total area that the sound wave receives is the area of the sphere, right? So we need to include that. So intensity is therefore going to be power over 4 pi r squared. 4 pi r squared. What is 4 pi r squared? The surface area of the sphere, because the sound wave, when we consider when the sound receives to point A, it's not only going to receive to point A, it's also going to receive to all, like, complete this around this complete surface area, right? Think about it in the three-dimensional manner, right? Okay, we need to find the power. So power is going to be intensity into 4 pi r squared, right? So power is equal, intensity is given as 0.7, 4 pi is said to be as 22 over 7, and r squared is 10 squared. So therefore we are going to get something around 880 watts. So the power of the sound source is going to be 880 watts, right? So yeah, right, that's done. All right, so let us discuss the seventh question, right? So in the seventh question, it says the intensity level. So this question is related with the intensity level, guys, right? So, intensity level refers to the loudness of sound, right? So the intensity level at a certain place where the intensity, so you need to know, right? So intensity and intensity level are two different things, right? So intensity level refers to something closer to loudness, right? So intensity, and then they're saying the intensity level at a place where the intensity of sound is this much, 4 microwatts per square meter, right? They have given the threshold intensity. What they are asking is the intensity level, right? It's not that difficult, right? So yeah, let's try it out. All right, so it's the seventh one, right? Okay, so simply, how do we write the intensity level? Beta is equal to the 10 log I over I naught, right? So this is the equation for the intensity level, right? So we need to find the intensity level of which sound intensity. The sound intensity that we need to find the intensity level of is 4 micro means 10 to the power minus 6, right? Micro watts per square meter, right? Okay, and then what is the threshold intensity? 1 into 10 to the power minus 12. So if you simplify this cancels. 10 to the power minus 6 remains below. So what happens is 10 log 4 into 10 to the power 6 comes up, right? When 10 to the power minus 6 is going to be taken up, its index is going to change into 10 to the power plus 6, right? Sorry, power, right? Okay. Therefore, the sound intensity level or the loudness is 10. You can write this as log 4 plus log 10 to the power 6. So beta can further be written as, what is log 4? Log 4, they have asked us to take it as 0.60. 0.602 plus log 10 to the power 6 is 6 log 10. 6 log 10. So therefore, beta can be written as 10, 0.602 plus 6 into 1. Log 10 is 1, right? Log 10 is 1. Log 10 base 10 is 1. So therefore, if you simplify this, you're going to get 10 into 6.6 something. All right. So beta is going to be 66 decibels, right? So that is the units of the loudness, right? So therefore, simply the answer is going to be 66 decibels, right? The fourth one. All right. Okay. Right. So let us go for the 8th question. So this is also not going to be a very difficult one. This is very similar to the 6th question. So one last time, let's discuss this kind of a problem, right? So since in that case you will remember the equations and all, you'll get familiar with the equations. So for that sake, let us discuss this problem. So it says for a particular experiment, uh, a sound intensity of this much is required, right? At 4 meters apart from the loudspeaker. Find the minimum power of the speaker. So yes, simply this is which question exactly? The 8th one, right? Okay, in the 8th one, so it's like this. What they're saying is there is a certain point. From this point, at a distance of exactly 4 meters, right? 4 meters, a sound intensity of how much is required? A sound intensity of, as they say, 1.4 is required. 1.4 watts per square meter is required, right? So in order to obtain this amount of intensity at the point, for example, let's say A, what should be the power of the sound source placed at O? You need to find the power, right? So we know the sound is going to not only going to be traveling in a linear way, it's going to travel in 360 in a 3-dimensional manner. So when the sound reaches the point A, it's not only going to reach to point A, it's also going to reach to a sphere of surface area 4 pi r square, right? Okay, fine. So let us use the equation I is equal to, you remember this equation, right? P over 4 pi r square. This kind of, when you come across this kind of problems, you do not have to go from the basics, right? So I is equal to E over AT, and then E over T is P. Likewise, you do not have to go. You can straight away use this equation, right? So intensity is equal to power over 4 pi r squared, right? So what you require is the power. So in that case, I into 4, 22 over 7 r squared, right? So what is the intensity? 1.4, and the radius is 4. So yes, let us substitute it. 1.4 into 4 into 22 over 7, 4 squared. So if you simplify this, you're going to get something around 70.4 watts, I guess, right? So you're going to get something around 70.4 watts when you simplify this problem. 8th one. All right. Right. Okay. So let's go for the 9th question. So it says, how much more intense is an 80 decibel shout than a 20 decibel whisper? How much more intense? So this states how much more louder is this 80 decibel shout from this 20 decibel whisper. So when something is measured in decibels, it's going to be something related with loudness. So simply what they are asking is how much more loud is an 80 decibel loudness than a 20 decibel loudness. Yeah, pretty much the simple case, right? So yes, let us see. Right. So this is the problem 9, right? So here it says there is an 80 decibel sound. So therefore, let's write the loudness equation for it, right? So 10 log I over I naught, right? So initially they have given the shout is 80 decibels. 80 decibels, 10 log I1. Let's assume the intensity of that 80 decibel loudness is I1 over I naught. I naught is a constant value, right? So let's assume this is the first equation. And then they are also saying something, there is another loudness that is a whisper, actually 20 decibel whisper. Let us find the intensity of that as well. Let's assume it is I2, I naught, right? I naught is always going to be the same, right? Because it's the threshold intensity, right? So we need to find the difference between these two intensities, isn't it? How much more intense the difference between these two intensities, right? So what I'm going to do is I'm going to subtract the first equation from the second equation, right? So okay, 80 minus 20 is equal to 10 log I1 over I naught minus 10 log I2 over I naught, right? 80 minus 20 is 60. Take 10 out, log, take 10 out, log. So you can write this as how? I1 over I naught over I2 over I naught according to the principles of logarithm, right? You can write it as this, right? So basic mathematics. So these things are going to get cancelled out. I naught to I naught is going to get cancelled out, this to this. So what remains is 6 is equal to log I1 over I2, right? Log I1 over I2. So if you kind of convert this number, logarithmic number, into a standard number, right? So it's going to be written as, so actually here log 10 base, right? So this should be raised into the power, while this should be taken into the base, right? So you can write it as 10 to the power 6 is equal to I1 over I2, right? So which means I1 is equal to 10 to the power 6 times I2, which means I1 is 10 to the power 6 times intense. I1 is 10 to the power 6 times intense as that of I2. I2 is the intensity related with the whisper, and I1 is the intensity related with the shout. So the shout is 10 to the power 6 times intense as that of the whisper, right? So that's the solution, right? So let's discuss the 10th question as well. All right. So it says, how much energy do you need to shout with the 80 decibel loudness continuously for 1 minute if the sound level is measured 2 meters from you? How much energy do you need to shout with a 80 decibel loudness continuously for a minute if the sound level is measured 2 meters from you, right? Okay, it's like this, right? So simply it's the 10th question, right? So the 10th question is going to be this kind of a problem, right? So you need to first of all understand the question. So this is you, right? So you need to shout, right? So when you shout, the loudness is measured at a distance. The loudness is measured at a distance 2 meters from you, right? It's measured at a distance 2 meters from you, and this loudness somehow should be 20 decibels, right? This loudness should be somehow, 80 decibels, right? 80 decibels, and yeah, 80 decibels. And you need to shout for how long? You need to shout for 1 minute, which means 60 seconds. So if you shout for 60 seconds, what is the energy that you will have to produce in order to shout with such a loudness, right? So yes, if energy is going to be related into this problem, we know the only way the energy relates is I is equal to E over AT, right? I is equal to E over AT, right? So in that case, I is not known, right? So I is not known. So we can easily, first of all, find I. How can we find I? From the equation beta is equal to 10 log I over I naught. First of all, let us find I naught. Sorry, I. So beta is 80 decibel. Let's find the intensity corresponding to 80 decibels, right? 10 log I over 10 to the power minus 12, right? So this cancels. 8 is equal to log I plus log 10 to the power 12, right? This comes up, and then the multiplication, somehow you are going to come up with this kind of a simplification, right? So 8 is equal to log I plus 12 log 10. So this is exactly going to be 1, right? So log I in that case is going to be what? Minus 4. Log I is minus 4. So I is going to be in that case 10 to the power minus 4 watts per square meters. Now I have found the intensity that is heard at this point, 10 to the power minus 4 watts per square meter, right? So if I know that, I can easily find the energy, right? From the equation what? From the equation, I is equal to E over AT, right? E is what? Intensity into area into time. Energy is I is what exactly? 10 to the power minus 4. Area is 4 pi r squared. So the sound is going to be by a sphere of surface area which has a radius of r is equal to 2. So 4 pi r squared 2 squared for how long? For 60 seconds, right? If you simplify this, you are going to get a certain answer, right? So it's going to be 0.288. So the answer would be, if you simplify, 0.288 joules, 0.288 joules. All right. Okay. So that question is also done. Right. So let's go for the 8th question, the 11th question as well. So it says, what is the intensity ratio of two sound levels that differ by 10 decibels, right? So what is the intensity ratio? What they're asking is the intensity ratio of two sound levels that differs by 10 decibels, right? So, okay. So if we assume this is the 11th question, right? So in the 11th one, right? So let us assume there is a certain loudness beta 1 and the intensity corresponding to it is I1, and then another loudness is there beta 2, the intensity corresponding to it is I2, let's assume, right? So let us assume what they are saying is, when the loudness, the difference between the loudness is 10 decibels, then what is the ratio between it, right? So how can we relate beta 1 and I1? So from the equation, 10 log I1 over I naught minus beta 2. How do we relate beta 2? 10 log I2 over I naught is equal to 10. So take 10 out, take log, and then I1 over I naught over I2 over I naught. So is equal to 10. 10 to 10 cancels. All right. I naught to I naught cancels. And in that case, log is equal to I1 over I2. I1 over I2 is equal to 1, right? So if we convert this, I1 over I2 is equal to 10 to the power 1. It's going to be 10 to the power 1, which means the ratio between the two is going to be what? 10, right? The ratio between the two intensities are going to be 10.